In this video, we're going to talk about the electrolysis of an aqueous solution of sodium chloride. So we're going to have two graphite electrodes. You could also use platinum or some other inert electrodes. And this is going to be the positive terminal of the battery, and this is the negative terminal of the battery. So in this solution, we're going to have water and sodium chloride. Now let's say we also have HCl. So the solution is acidic. We'll say the pH is 0. So we have a 1 molar solution of HCl. Identify the anode and the cathode. Also, determine the reactions that occur at the anode and at the cathode. Electrons are going to flow towards the positive terminal of the battery and going to leave from the negative terminal of the battery. Electrons always flow from the anode to the cathode. So the right side, it represents the cathode electrode, and the electrode on the left side is the cathode. On the right side is the anode. Now the anode is going to be positively charged since it's attached to the positive terminal of the battery, and the cathode is negatively charged. And so we're going to have an electric field that flows from the anode to the cathode. Now the negatively charged ions, like chloride, is going to feel a force that will accelerate it in a direction opposite to the electric field. The positive charges, like the sodium ion or even the hydrogen ion, they will both feel a force that will accelerate them in the direction of the electric field. So basically, anions like chloride flow towards the anode, and cations like sodium and the hydrogen ion, they flow towards the cathode. So cations are ions with positive charges, and anions are ions that contain a negative charge. So let's talk about the oxidation reactions that can occur at the anode. Chloride can be oxidized into chlorine gas, and the cell potential for this process is negative 1.36 volts. Now water can also be oxidized at the anode, and under acidic conditions, if we have a solution of 1 molar HCl, the cell potential is going to be negative 1.23 volts. So using this information, which one of these reactions will occur at the anode? Is it going to be the chlorine reaction, the oxidation of water, or is it a bit of both? Well, it depends on how close these values are to each other, and it also depends on the concentration of chloride in the solution. Because water is so plentiful, if we have a dilute solution of NaCl, this can still occur. However, if we have a concentrated NaCl solution, then this one can occur as well. Now, a second thing you need to take into account is that this reaction doesn't give you the whole picture. For example, oxygen is at a -2 oxidation state in water, but in pure oxygen gas is at an oxidation state of 0. Now, before it goes from -2 to 0, it has to get to 1, -1 that is. And so you need to be familiar with this reaction as well. Water oxidizes first into peroxide before it turns into oxygen gas. And the cell potential for this reaction is very high. It's negative 1.78. So it's much higher than this one. That's the first step. The oxidation state of oxygen in hydrogen peroxide is -1. And then in the next step, hydrogen peroxide gets oxidized into oxygen gas. And the cell potential for that is negative 0.68 volts. So the second step is relatively easy, but the first step is a lot more difficult. So it's easier to oxidize chloride than it is to oxidize water because it takes a lot of energy to generate hydrogen peroxide. H2O2 is a very powerful oxidizing agent. And so that's why chlorine gas will form at the anode, is because the first step of the oxidation of water, has such a high cell potential. It's not easy to oxidize water into hydrogen peroxide. So if you have a concentrated solution of NaCl, this is going to be the principal reaction of the anode. Now if you have a very dilute solution, then this reaction can occur because there's a lot more water molecules than chloride. Now if we have a standard 1 molar sodium chloride solution, it's safe to say that this is going to be the principal reaction at the anode, due to the fact that this value is significantly higher than this value. So this reaction will be more spontaneous. Even though they're both non-spontaneous, negative 1.36 is higher than negative 1.78 on the number line. Now let's focus on the reactions occurring at the cathode. So what reduction reactions can take place? So we know that the sodium ions and also the hydrogen ions, they feel a force that will accelerate them towards a negatively charged cathode. Now under acidic conditions, hydrogen can acquire 2 electrons and turn it into hydrogen gas. The cell potential for this is 0 volts. Now sodium has a very high potential, and so it's negative 2.71 volts for sodium. Therefore, it's safe to say that this reaction will not occur because 0 volts is a lot higher than negative 2.71. So therefore, let's combine the reactions at the anode and the cathode to get the net reaction. So at the anode, the principal reaction will be the oxidation of chloride. And at the cathode, the principal reduction reaction will be the reduction of the hydrogen ions into hydrogen gas. So if we add these two to get the net reaction, it's going to be the conversion of hydrochloric acid, which is H plus Cl minus, into hydrogen gas and chlorine gas if we have an aqueous solution of sodium chloride. Now, if we have a molten solution of sodium chloride, that is, if there's no water, but if we have liquid sodium chloride, maybe at a high temperature of 600 or 800 Celsius, then in this case, only chlorine gas will form at the anode, and sodium metal will have to form at the cathode, because that's the only thing that can take place if you have a molten solution of sodium chloride. But if you have an aqueous solution of sodium chloride, if it's dissolved in water, this reaction will not happen in water. If it did, sodium will immediately react with water, producing hydrogen gas and sodium hydroxide. Now the sodium hydroxide will react with the acid in the solution, and so this will go back to sodium chloride plus water. Now what if the solution wasn't acidic? What if we had a basic solution? How will everything change? So what reactions can occur at the anode? So it's still possible that chloride can be oxidized into chlorine gas, and so that still can have a cell potential of negative 1.36 volts. Now if you oxidize water under basic conditions, hydroxide will be oxidized, and this will be oxidized into oxygen gas plus 2 water molecules plus 4 electrons, and the cell potential for this will be only negative 0.4 volts. Now both hydroxide and chloride are anions, so because they carry a negative charge, they will be attracted to the anode. Anions always migrate towards the anode, so these can occur. However, the cell potential for this reaction is a lot less than this one, so this reaction is not favorable. So under basic conditions, this reaction appears more plausible due to the lower cell potential. The higher cell potential. Negative 0.4 is higher than negative 1.36, so this reaction is more spontaneous than this one. This one is less spontaneous. Now, even if some chlorine gas molecules were produced at the anode, the chlorine gas molecules will immediately react with hydroxide, converting into the hypochlorite ion, plus chloride plus water. So hydroxide will immediately react with a chlorine molecule, causing this to leave. And so initially, you're going to get the hypochlorous acid, which looks like this. And then you'll get chloride. Now, since the solution is basic, the hydroxide ions will immediately remove this hydrogen. And hydroxide plus H, that's going to turn into water. And so once HClO loses a hydrogen, it's going to turn into the hypochlorite ion. And so these will be the products of the reaction if some amount of chlorine gas evolves at the anode. But for the most part, this is going to be the main reaction at the anode. Hydroxide can be oxidized into oxygen gas. Now what about the cathode? Under basic conditions, this reaction will not occur. The cell potential is simply too high. Now this reaction can occur under basic conditions. Water can receive electrons and turn into hydrogen gas plus 2 hydroxide ions. And the cell potential for this is negative 0.83 volts. So it's a lot easier to get this reaction going than this one. So under basic conditions, we're going to have these two reactions. Now if we're going to add this reaction and this one, we need to make sure the number of electrons are the same. So we got to multiply this reaction by 2. So it's going to be 4 H2O plus 4 electrons, generating 2 hydrogen molecules and 4 hydroxide ions. And then if we add it with this one, we can get the net reaction for this process. So these will cancel. We can cancel the hydroxide ions and then subtract both sides by 2 water molecules. So on the left, we're going to have 2 H2O molecules. On the right, 2 hydrogen gas molecules and 1 oxygen molecule. So under basic conditions, the net effect will be the electrolysis of water into hydrogen gas and oxygen gas. So it's safe to say that these reactions will not occur to any significant extent. So these will be the main reactions under basic conditions.